So today we'll start with 18FT 305 Basics of Fiber, Yarn and Fabric Manufacturing. We are at Unit 4, that is the Modern Spinning Systems. Now in this unit, the lesson 1, we will talk about the modern spinning systems, the definition and classifications, and we will cover the rotor spinning, the friction spinning, air jet spinning and the Bobtex spinning process. Now in the introductory part we should cover here the different spinning system. We have already seen the ring spun yarn, we have seen the dry spinning, wet spinning and melt spinning operations. Now there are various upgradation has been done in the spinning industry. So a lot of other spinning systems have come into the picture to produce different fineness of yarn. Speed of operations also comes into the play. Twistless yarn has been produced, friction spinning has been produced, and we have also produced the open end spun yarn, the coarser varieties of yarn which are normally used in the different denim industries now. So depending upon the products produced by the fashion industry, now different types of yarns are getting produced. So those yarns cannot be produced only in the ring frame. So that's why different modernization process has been adopted to it. So some of the processes, the preliminary overview of these processes are covered in this lesson 1 of unit 4. Let us see those processes. Rotor spinning. So this is one of the modern system of spinning, and this is shown in the schematic view or the diagram in the figure. Now how it works and what does it refer? This rotor spinning is also called open-end spinning. Open-ended or break spinning is referred to as rotor spinning, where process sequence is less than combed as well as a carded yarn. So some of the processes can be eliminated in this rotor spinning system, which will make the process faster to get the yarn and produce the desired fabric and to supply to the garment production units. So that's why such kind of modern spinning system are invented and commercialized. Now rotor spinning, if you see, this is one of the view of an industry where this rotor spun yarn is getting produced in the industry. Now in the rotor spinning, if you see, what is the main feature? The roving formation in simplex machine is not required to rotor spinning. So which is required in the ring spinning operation, the roving formation, that is eliminated in the rotor spinning, because here drawn slivers are fed to the machine directly. So that is one of the advantage of this rotor spinning system. Now what are the important features of this rotor spinning? The production rate of rotor spinning is 6 to 8 times higher than that of ring spinning, where coarse yarns are made within a range of 5 to 40 cotton count. So these are the unique features, that production rate of rotor spinning is higher than the cotton spinning or the ring spinning. So this is also another figure is there for this open end spinning and the rotor spinning in the industry. Now this type of yarn, as you can notice here in this image. So how rotor spinning is there and what type of fabrics it produce? So obviously you can understand the denim. So denim fabric is produced out of the rotor spun yarn. So medium to low quality yarns here are produced, and these yarns are getting used to make denim, twill, dungaree, chinos, as well as any heavy fabric. Since it is a coarse yarn, so a lot of heavy fabrics which are commercial fabric for producing the garment, so those can be produced by the process of rotor spinning operations. Now you can see the schematic view again of the rotor spinning system and how it is getting produced. So rotor spinning is much popular in use due to the high production rate, less wastage percentage, very important here, because in the ring spinning lot of wastage are getting generated which is not there in the rotor spinning, and high usable denim is produced to make the blue jeans. So maximum jeans actually is produced, the yarn is produced in the rotor spinning system because of the coarseness of the yarn. Now obviously what is the flow chart of the rotor spinning system? Let us understand. One is the mixing process, as in the blow room we have seen, carding, then first drawing frame, second drawing frame, and no roaming operations, as we have already mentioned. So it goes directly to the rotor spinning system. So obviously the time is getting saved here. So that is the rotor spinning flow chart. Let us go into the another spinning system, that is called the friction spinning. What do you mean by friction spinning and why it is useful? This is also a machine used in the friction spinning machine is used here, and it is an open end or core type form of spinning or both combined together, wherein the yarn formation takes place with the aid of frictional forces in the spinning zone. So frictional forces are there by which the yarn is getting produced here. That is called friction spinning. Again, a schematic view of this diagram, you can see that how the friction is getting produced here in these operations. Only the forming yarn rotates at high speed, while the other elements rotate at low speeds, and yarn rotates up to 3 lakh RPM due to very low spinning tensions. So that is the unique thing about this friction spinning, rotation of the yarn at 3 lakh RPM, because tension is not there, spinning tension is not there. Now in friction spinning, as we can see that it is done through friction, as we have already mentioned. So very high production speed of 300 meters per minute can be attainable in these friction spinning machines. Again, the schematic view, if you see, this system is much more versatile in terms of fiber used than air jet and rotor spinning system. So it is a versatile system of spinning, friction spinning. Production rate and preparation cost is also less here. This is also one of the system has been shown here, the friction spinning system. Low end breakage rate and higher machine efficiency. This is quite obvious if the breakage of the yarn is not there while it is running. So efficiency of the breakdown of the machines will not be there, and breakages of the yarn will not be there. So definitely higher machine efficiency will reach there. So in this particular production unit, you can see the friction spinning, where elimination of rewinding is also another important feature. So rewinding process is eliminated here. Now if you see again closely the friction spinning, the system has automatic piecing and doffing arrangement. This is also another advantage of friction spinning system. And the path of the machines has been shown here. This is also a very improvised form of friction spinning where the yarn produced is cleaner as the drum suction removes the dust and trash particles. So it is a clean yarn is getting produced by friction spinning process. Now let us go into another spinning system that is called the air jet spinning. How it works? This is one of the industry where air jet spinning machine is running. Now what is the unique feature of this? Twist is inserted to the fibers mostly on the yarn surface by the vortex created in one or two air jet nozzles. So yarn surface actually the twist is inserted on the fibers by the air vortex system. That is the unique feature of air jet spinning. Now if we go into the details, this is also called the fascinated yarns. Air jet spun yarn is called the fascinated yarns. So these type of fascinated yarns are produced having outside binding fibers wrapped around a core parallel fibers. So that's why this is not a normal fiber or normal yarn, because it is having binding fibers wrapped around a core of parallel fibers. So fascinated yarn production system, that's why based on false twist principle. Why? Because twist is imparted pneumatically in air jet spinning. So these are the unique features of air jet spinning. Now let us see it is in more detail how it works. The resulting yarn consists of a core of parallel fibers and a sheath of wrapped fibers. So this is the unique advantage or unique feature of air jet spun yarn, where there is a core of parallel fibers and a wrapped fibers sheath of wrapped fibers or twisted fibers around it. Now this is suitable for the use in the pile or terry fabrics, but not in the ground. Okay, so that is the air jet spinning advantages. Now there are other important areas of air jet spinning. As you can see, the nozzles of the first jet are set to give a counterclockwise vortex, producing a ZS false twist action. As we have already mentioned that false twist is getting imparted. The second jet gives a SZ false twist action. The pressure applied to the jets are such that the jet 2 has the higher twisting vortex. So this is the mechanism of air jet spinning. As we can see, a flow diagram or the flow chart of air jet spinning. So as you can see, this card, draw frame 2, draw frame 3, and then the air jet spinning process is there. So air vortex is the main thing here which is getting created. Now as you can see in this figure, little bit of mechanism. A 3/3 high speed roller drafting unit is there. A central cylindrical channel that is called a spinning channel, through which the fiber ribbon from the drafting unit passes. Now inclined to the channel axis but tangential to its circumference are the 4 nozzles through which the compressed air is injected into the channel and creating a vortex airflow, which is shown in the figure. Now we come into the last type of spinning, that is the twistless spinning, or we call it as a Bobtex spinning, as is shown here in the figure. It is the composite yarn formed by melt spinning extruded fibers from a spinneret or by coating filaments with a molten polymer, followed by coating the emerging fibers with short staple fibers. So this is the unique feature of a twistless spinning or Bobtex spinning. Now resulting matrix is immediately twisted, causing the staple fibers to embed in the extruded fibers before cooling, as is shown here. And the resulting composite yarn is formed at a very rapid rate on the Bobtex spinning apparatus developed for this process. So these are the unique features of this twistless spinning. Now this is also called the twistless spinning because no twist is imparted. In this system, liquid or powder polymer adhesives are applied to sliver or filament toe, and the adhesive activated by heating or steam to cause the individual fibers to adhere to one another. So cohesion is getting improved by this process. In some systems, after the textile substrate formation from the twistless yarn, the adhesive is removed to improve the aesthetics of the resulting textiles. So these are the unique features of Bobtex spinning or twistless spinning. Adhesive used, what are those adhesives? Polyvinyl acetate, polyvinyl alcohol and starch. So if we try to summarize the process in this lesson 1 of unit 4, we can see that new spinning systems we have seen here, that is, one is called the open end and another is called the twistless. So we have seen the open end systems, rotor spinning, friction, air jet, and then in the twistless spinning we have seen the Bobtex spinning. So these are the different varieties of new spinning systems available. We will see more into these new systems, their operations, their characterization, etc. in the next lessons. So thank you very much for this lesson 1, and we have seen here different types of modern spinning system by which we have understood that it is not only the ring spun yarn but also different varieties of yarns are there available which are used in the apparel industry for producing different types of fabrics which are used in the fashion industry. So that's why it is not only the ring spun yarn, open end spun yarn is also required at a faster rate, and also the twistless yarns are also required depending upon the product specification. Thank you.